Good evening. Today I've prepared a brief gist about what neural networks are, so let's continue on. Neural networks are basically universal approximation functions. So, why are they called this? First of all, I will explain what a neural network is. A neuron is the basic building block of a neural network. It consists of an activation function like a ReLU or a sigmoid. It can be anything. It is just a function given some input x that outputs some output y. This activation function predicts how the input received by that particular neuron should propagate forward. Let us consider a basic problem such as the MNIST dataset. So the problem deals with predicting handwritten images of digits. The first step is to squash the image. Suppose you have a 28 cross 28 image, pixel wise. Squash the image into a vector. So I say 20 times 20 is 120, and you will have that many number of dimensions. So each neuron consists of an image matrix now which is squashed. This is propagated forward. This is the input layer basically. So you will have the 28 cross 28 input dimensions, and after that you will have your hidden layer. We use the hidden layer in multi-layer perceptrons to predict accurate output. It increases the accuracy in cases of non-linearity and all of that. Or you require it for non-linearity. Non-linearly separable problems, you require multi-layer perceptrons. Now we will talk about matrices and how matrix multiplication in particular and matrix addition and other such matrix operations fit perfectly into this problem. When you consider it, you can put each neuron is basically predicting something. It has a value from 0 to 1, between 0 to 1. So you put this all into a matrix, vector matrix multiplication, and then you get an output. So finally, the output layer will consist of 10 neurons. The MNIST dataset, like I said, predicts handwritten images of digits. So there are only 10 digits, 0 to 9. So the output will obviously consist of 0 to 9, and each neuron in the output layer will have a probability wherein the maximum probability is the output. Suppose I give an image of 3 and the output is predicting 4 with a maximum probability of 0.6. That means there is something wrong with this network. We must correct it now. So what we will do here is put every single parameter in the network into a cost vector. Everyone knows what a vector is. So a cost vector, basically, we will put everything into a cost vector. And additionally, I forgot about things like activation. What is that? Learning rate and bias. These are network tuning parameters, the most fundamental ones. Now the cost vector has to be optimized to minimize its loss. This is done using multivariable calculus. The process is called gradient descent. So basically a gradient is the direction of steepest ascent. So we use the negative of the gradient, why it is called gradient descent basically. So once we receive all the optimized values of the network, we reinsert this and retrain the network once more. So over iterations and iterations of this particular process, we get an optimized value of that cost vector, which is basically all the network parameters that have been fine-tuned in an n-dimensional space. So I think this is what is called backpropagation also. And if you wish to learn more, please look at Grant Sanderson's videos. He is goes by the alias 3 Blue 1 Brown on YouTube. So additionally, this is just a deep neural network. There are other neural networks such as convolutional neural networks, best at image classification, large language models such as generative pre-trained transformers which use attention mechanism. You can read the paper Attention is All You Need by, I think Google wrote that. Google engineers wrote that. My sporadic knowledge basically ends not in deep neural networks. I know what a convolutional neural network, LSTM, RNN, and LLM is, but maybe another time. Okay, thank you.